Hi, my name is Aaron Wanjala, and today we're going to talk about what programming should look like in 10 years. And that sounds broad, but I swear I have a specific proposal. And I just want to start by saying a couple things about myself. One just fun fact about me is that I have what I consider a deep interest in the law. I listen to and read about a bunch of legal topics like Supreme Court news, tech and IP law, and sometimes I'll just go to the Criminal Code of Canada and read through it just like to see how the logic is laid out, especially for like a given sentence. So I often say that if I was born much earlier, or if computer science just hadn't been as accommodating and enticing, I probably would have gone into law instead. Luckily, for the sake of this talk, I did steer towards computer science, and I swear that by the end of the talk, I will have covered an interesting technical topic. The number one thing that pulled me towards computer science, though, or programming to be more specific, was the fact that with nothing but my own time and attention, I could sit down and write an application or a script that really did something, and it could be valuable in some way. This aspect of like making something out of nothing, that sensation, without the need of components like the Raspberry Pis or Arduinos that I'd messed with a little bit, it felt like something between magic and a superpower to me. And that once I experienced that, that's when I decided that I would try to be a developer. And even if I didn't get there, whatever I ended up doing, as long as it was close, software related, computer related, it wouldn't feel like work. Then I'd be set. That experience really meant a lot to me. And during this talk, we will be exploring what programming experiences or developer experiences have typically been like through different kind of computing eras, and how I think they should be in the next 10 years. Since that moment, I have spent just about 6 years as a full stack developer. By the way, how many people in the crowd have some engineering background or would consider themselves to be an engineer or a developer? That's the term I prefer. Just show of hands. Okay, yeah, fairly technical crowd. Good stuff. I think this will be especially relevant then. For myself, for my background, most of my time has been spent building Angular apps on the front end, all the way from JS to 11. And then those are often backed by Spring Boot apps, so Java, and then we use Oracle databases heavily. At least that's been the stack that I've spent most of my working time in. But on my own time for personal projects, I've roamed around different stacks, different products. Lots of time spent on Google Cloud Platform with Firebase, making progressive web apps and such. And yeah, it's been fun. But yeah, now that we know each other a little bit more, um, let's talk about the question in the headline a bit. What should computing look like in the next 10 years? To help us answer this question, I want to establish a term that we'll be using for the rest of the talk. By developer or developers, I really mean anybody who contributes to, making a computer or a piece of software. Kind of broad, but I think it'll help. And with that, I think we'll get started. To explore this question, though, what should programming look like in 10 years? I think a good way to explore answers to it is to look at barriers to entry across a few broad eras of computing. So let's do that. The year is 1984, 1974, sorry. Paul Allen and Bill Gates had to wait until the release of the Altair 8800 to seize on the opportunity to write a basic compiler. And that was meant to serve the burgeoning dev community that they were both a part of and saw a lot of promise in. And I say burgeoning, and that's because it was truly an enthusiast market at this time. The world really only had a few handfuls of developers, but there were enough. Altair Basic launched, and it was the first product of Microsoft. It was kind of two different words there, hyphenated. And for those who weren't around to be nerds in 1974, the Altair 8800 launched as a microcomputer at the time, and it's now praised as the first commercially successful personal computer. This was a huge step, of course. It was a step away from mainframes and towards cheaper desktop computers. And while I personally find things like clock speeds and microarchitecture and how they've kind of gone over time, where they were at the 8800, really fascinating, and I'd be happy to give a talk about how far that's come. What I really want to focus on here for this talk is just the computing experience that the Altair provided. So in a word, I would describe the computing experience of this era as expensive. Prohibitively so. It was financially expensive, like just to get the Altair, which is pictured there, it was 439 US dollars, which that's in 1974 dollars. That's $2,100 today. And that was if you just wanted the parts. If you wanted just the parts to come in a box and you assemble it yourself. If you wanted it assembled, it was $621 at the time, and that is about $3,000 today. So pretty crazy ticket price. And it was also expensive in terms of the time and attention required to be a developer. Even once you're in the door, the thing that was like the Altair was so difficult to use that it was clear that in order to have the computer revolution really take off, Bill and Paul needed to create like an on-ramp to let users program it more easily. And in Malcolm Gladwell's book Outliers, he mentions that Bill Gates credits his early and frequent access to computers with giving him enough practice, the famous 10,000 hours, to lead the computer revolution of his day. So, little fun fact. And once Microsoft had launched BASIC, that's great. It was far easier for people to code on the Altair, but we're still talking about writing assembly code, which are specific memory instructions, and they'd have to punch them out on paper tape with little holes to represent binary numbers. And then once you'd done that, then you would feed that little paper tape into a paper tape reader, or if you were kind of upmarket, you would just get a teletypewriter and type them in. But that may run you a couple extra $100, and then you would be able to see if you made an error after all that. So make no mistake that if I had been a teenager in 1974, I would have gone straight into law school. There's just no way that my family could afford to give me access to a computer, even as a user. And then if I somehow got the opportunity to try development, chances are that my experience would have been far less than magical. So, yeah, pretty grim in 1974, in my opinion. Moving on, though, jumping ahead 30 years, 2004. Computing has come a long way. Way down in price, way up in speed. The computing experience is far cheaper, more enjoyable, more accessible, like across the board. But there are still some significant limitations compared to now. For developers specifically, though, a lot of progress had been made. It was far easier to code, far cheaper to learn, and in just a number of weeks, a developer like Mark Zuckerberg could create a service like the Facebook in his dorm room, if they were willing to cut a few classes, of course. But importantly, he was able to affordably create and host an early version of a service like the Facebook in his dorm room, which was a very new capability. A lot more was possible for many more developers, just across kind of computer science or programming. But standards and practices and best practices were still very molten. For example, we'll look at Netflix. At this time in 2004, they were still building a physical DVD rental service. Netflix wouldn't launch their online streaming service until 2007, and internally they would struggle with how to structure and publish usable REST APIs until around 2009. You can see some examples of other apps in the family, and their APIs would allow other services to ask Netflix structured questions about their data, receive structured answers in return, and then they could kind of build on and increase the value in the Netflix ecosystem. But yeah, this lack of best practices and modern libraries with opinionated architectures that give developers kind of a authoritative right way to do things. If that's not present, it results in a lot of low value work being repeated and reinvented slightly differently by every developer for every project. So it's a real cost to the ecosystem. And so at the risk of sounding pessimistic, I would just call development at this stage bearable. Much better than before, not great compared to now. And to be fair, this is close to the time that I started taking interest in development. It's not ancient history. It's just not quite modern. So one last anecdote that I'd like to bring up before we move on to the next era is that somewhere around 2008, the place to be for young, ambitious university graduates kind of switched from high finance to computer science. And that may sound kind of random, but I think this is an important change to note because it's essentially the next generation placing a bet on which industry they think will be most promising, which, that's nothing to sneeze at. It's a great indicator for computer science at the time. Moving on. 2021, modern era. So at this point today, it's the barrier for entry barrier to entry for computing is very low, especially as a user. Kids start learning to use computers before anyone even sits them down to explain how they work, and the world just runs on modern computing. Being a developer today is much easier as well. If one wants to make a new service, new app, new website, not only are there like cloud services listed here that are out here um, basically free, trying to save you the hassle of setting up your own servers and maintaining them. They'll give you access to their services for free. Cloud service providers like Google, Amazon, Microsoft, they're vying to be the foundation of the modern economy. And it's easy to understand why, you know. It's a great piece of real estate if you can kind of pave the main street on which people kind of live their lives and run their businesses. It's a great place to be in. So yeah, the developer experience today is excellent. These companies have made it far easier to contribute to the web or to computing, but that change has not reached most people. Or if it has, it's not relevant to them. For example, like if I was to walk up to the average person on the street, most anywhere in the world, and say that, hey, Google Cloud Platform has these great free tiers. Like look at the screen. It's 4/hundredths of a cent for an hour of compute time, and you can build and run an app for free until you have thousands and thousands of users and ideally some revenue. Then you start paying. That doesn't matter to them. It's great in theory, but they aren't really empowered to be developers. Not yet. And the reason for that is that there's still a knowledge gap or expertise gap that's needed to be closed in order to leverage these cloud services. And that gap is keeping them out. If you are connected to the modern web, though, you benefit from like a massive inheritance. It's this wealth of knowledge and work from those who have come, before us, and added to it. And I see it as everybody's right, really, to either use that inheritance as they please, just as a user, or to be a developer and build on it. However, as cheap as cloud computing has gotten, as low as the barriers dropped, what's still there is prohibitive to most people on Earth. The expertise gap that you need to clear in order to exercise your right to the modern web is still too expensive for 90% of the world. And so to tie this back to the law a little bit, a right without a remedy is no right at all. So, the remaining problem. Let's talk about what's left in front of us. Say, for example, you recorded a video clip on your phone, and you'd like to slow it down, maybe add some lens flare, some basic video editing, or maybe another example, you have a great idea for a website, say a gift exchange platform for travelers going to different countries to share souvenirs with each other, and you can see it in your mind, but you have no idea how to build it, and you don't have access to a developer who does. Maybe you can't afford them. So how can we remedy this? Well, what if both sides of computing, both as a user and a developer, were no more difficult than explaining what you want the system to do next? After that, the system that you're either trying to use or design would either explain the steps on how to do it or show you the result. And then you could go from there. It would be kind of like standing over the shoulder of an expert and describing what you want them to do for you. And as I see it, that would bridge the gap. This descriptive model for computing, as I like to call it, because you're describing what should happen next, would allow anybody with enough interest to think through and express what the system should do next, step by step, they'd be empowered to use it or enable others to do so if they're making a new system. And finally, I think we'd have both a right and a remedy. I think that we're making leaps and bounds on the user side of this problem for the next era of computing with services like Dialogflow that allow developers to build like really rich conversation-based AI experiences pretty easily, and that makes life makes life easier for users. But I think we're not moving nearly as fast on the developer end of things yet. But I have spent the last couple of years thinking about it and working on this, and that's the specific proposal that I'd like to bring for the rest of this talk. So, let's say we want to get into this descriptive model of computing as soon as possible. What are we missing? Are we missing anything? If not, like when did we get there? Or since when are we not missing anything? Why hasn't this been implemented yet? Well, to answer those questions, we'll step through the timeline one more time, just focusing on kind of what was gained along the way for these purposes. By 1974, we had, development as we knew it was roughly beginning. That gave us a lot of new capabilities. It was still very difficult, but a lot of, new possibilities are added to the field of computer science. That said, no way that the descriptive model is implementable there. By 2004, we're getting closer, and development is, at the bearable stage. Computing is far more accessible. There are lots of great libraries that are built up, and these standards are starting to form. But it still may be unreasonably difficult to implement something like I'm describing here. It might be too early. By 2021, though, we've gained access to rich modern APIs. We have access to free, easy-to-use cloud services for computing, hosting, distributing, and importantly, we've built up and are still improving these opinionated architectures that provide an authoritative right way to do things that have been done before. And that makes the implementation of a descriptive model of computing or development far easier, as we'll cover in the next few slides here. I really think that the parts that we were missing at one point to enable, a system where you just describe what needs to happen next and have it happen, were in place around 2015, and that we as a field just haven't really jumped on the opportunity yet. But we'll get to that. So, if we were to start implementing this, where should we start? What's a good first cut? Well, I think that a good first candidate, an area to try this in, would be well defined. It would be a simple area of programming, and ideally an area where it's easy to deploy, and you can reach a large audience and allow feedback to be gathered quickly. I think web development fits that bill, so I think it's a good place to start. And that's why in 2019, I started working on Monolog. And just as it says on the screen there, as a proof of concept, I wanted to bring the barrier for web development down to zero, or at least to the level of having a conversation. As long as the user can describe the next change they want to see, they should be able to build their own website. But how does that work? How did we actually go about that? Well, the way it works is when a user lands on Monolog and selects an element on the page that they want to change, they're prompted to give a verbal command describing how they want to change it. Monolog then transcribes that command, interprets the specific intent behind that command, which is made much easier because they've selected a specific element, and that kind of it collapses the set of things that they might have meant by that on just what's possible with that element. If it's still unclear what they meant to do, then Monolog will clarify their intent with a follow-up question. Once that's figured out, Monolog makes the change on the web page instantly and logs the interaction. Those last two steps are extremely important. Ideally, they create the effect of having an instant feedback loop so that the user feels or is able to feel out what they're trying to build with minimal friction. They can just try something. If it doesn't look right, they take it back, they try again. At this point, I feel like I've done a lot of describing, but I'd like to do a live demo. And I'm not sure if the format of today's talk's going to allow that. No, that's okay. It is available at monolog.io if you'd like to try it. But we can talk through an example in the slides here for today. So imagine that you're a user, you've arrived at monolog.io, and you're looking at a website that you'd like to edit. So you select an element that you'd like to change, and then you're prompted to describe the change you want to make. So the user says, replace this with a picture of dogs playing in a park. They've clicked on an image, they want to replace it with a picture of dogs playing in the park. So next, the system interprets the command and responds with some relevant options for the user to pick from. Importantly, just to step back from this example, if this was something more complex, like the user said, I want MFA on my website, or something like that, where that is an area where having accessible opinionated frameworks to crib an implementation from would really simplify things. But luckily in this case, it's a very simple command, and so we're able to just pull out the query from the command and feed it into Shutterstock. It seems they're describing just wanting to change an image. And once the user has made their choice from the options presented, the change is made to the website instantly. a record of the interaction is logged in the bottom left there, and the log allows for changes to be easily reviewed or reversed, kind of like refactoring a code base. There's a little undo button beside each change to do that. So, um, to sum it up here, the proposal for what computing should look like 10 years from now is this descriptive model that we've kind of just described and shown an example of with Monolog. And with a couple tricks, I believe that this model is within reach and widely applicable today. Those tricks are selecting an element on which to act whenever possible, which you know makes it far simpler, really reduces the complexity of finding out what a user means with a given command. And then rather than building a new feature or interaction into your system, whether it's web development or anything else, if you can pull a technique for fulfilling a command from an existing framework, you should do that whenever possible instead. That makes the problem set much more manageable. And as long as the output is both a log of the conversation so that the user can easily make refactors, and a working product so that they can see the product or see the result of what they're doing and keep a loop or keep a short like iteration loop kind of in their head, then I think this is a real step forward because it allows them to easily go back and make changes, keep an easy handle on what they're doing. And so what would this mean if this was implemented and adopted and it had some traction? What would that really mean for developers? Well, it would mean that there's no need to learn to code in today's sense. This is a common sentiment in no-code circles, but unless you're trying to contribute to a descriptive model like Monolog or something like that, there shouldn't be a need for an average developer to learn a specific programming language. It's like how today you don't need to know how to address memory or set up a server in your dorm room in order to learn how to code and make an app. To take one step back from this this suggestion, while learning specific languages would become less useful over time, computational thinking, being able to break a problem down into kind of what steps you'd have to do next and how you'd want to lay that out in a system would become far more valuable because that would really be the only skill you would need as a developer, something between system designs and breaking things into algorithms. And to go just one order higher here, and I know I'm almost out of time, if this descriptive model is implemented and successful and widespread, what else happens? Well, that work would have to be repeated to account for the nuances of how different languages are spoken and written so that other languages can benefit from it. And I believe that developers, likely open source developers, or some other distributed development model, would deserve a reward for bringing their language into the descriptive model. And so that would kind of create something like a re-implementation gold rush among the languages where you're rewarded for how much you contribute to these descriptive models. Another thing I'd like to see is like math Olympiads, but for computational thinking, where contestants from around the world are given the same problem and then they compete to solve it with computational thought that they express in their own language rather than in math or code. And finally, I see a model like this as kind of acting in a way that's similar to like Xerox PARC, which if you're not familiar, Xerox PARC was the Palo Alto Research Center, PARC, created by the Xerox Corporation in the 70s. And it was credited with all these huge inventions that have really shaped technology ever since. These are inventions like object-oriented programming, or the concept of a desktop, or the computer mouse, the actual device. Things with just like incalculable value to our economy, all coming from just a few hundred academics in Palo Alto. But since I see this model kind of welcoming the next billion developers to the web to contribute from wherever they are rather than just Palo Alto, I can just imagine all the value that they'll create with all their ideas that were previously priced out or they weren't able to implement. And so when I see all the promise from a model like this kind of floating in front of me, it really reassures me that yep, this is worth investing time in. This should be my life's work. And I'm confident that, with or without my contributions, this will happen at some point. So I guess I'm a bit of an optimist in that way, but I'm an impatient optimist. And so I'm pushing as hard as I can for it to happen as soon as possible. And I think you should be too, because whether you're a developer or not, when this happens, it will affect all specialties, all professions that touch software, whether that's video editing, CAD modeling, game design. It won't just be developers. And I'm also confident that the world will be much better for it. So, yeah, thanks very much.